The broadcast is now starting. All attendees are in listen-only mode.
Okay, hello everyone. So welcome to the LevelUpLabs webcast here at SANS. My name is Matt, and I have the honor of talking you through that topic and letting you know a little bit about what LevelUpLabs are and how to build your own labs pretty easily, what to take care of, what to do, what not to do, and all of those things. During the webcast, you do have the ability to ask questions. You can do that by just putting the questions into the question bar on usually the right-hand side of your screen in the GoToWebinar application. You just put that there, and we'll go through a Q&A session at the end of the webcast. So who am I? So my name is Matthias Fuchs. Some call me CyberFox because Fuchs translates to fox in English. I'm currently head of investigation and intelligence at InfoGuard, which is a Swiss cybersecurity organization running a SOC, and my part is running the incident response department. So we're getting bigger all the times, and the incidents are getting more interesting. You know, attackers get more and more challenging. You can basically find me on Twitter as well. And I'm teaching the 4508 class at SANS. What I did recently is I released a tool for incident response management, which is called Aurora. If you're interested in using that, then just have a short look at my Twitter feed, and I think the last couple of entries should refer to that. So if you're providing incident response services in some regard, no matter if you're doing it internally or externally, have a look. It might help you, and your feedback helps me to well, get that tool better and more suitable for your needs. So first of all, why LevelUpLabs? So SANS has started a program like a year ago or so that was called LevelUp. And the idea was to show some sort of a roadmap for people who are in IT or maybe not even in IT, that told them a good way to become a security professional. Right, so there was a test, and I think it's still online. There's a test where you can go to through a couple of questions, and you will, after the test, receive an email that lets you know where you're good at and where you do have potential to develop some more skills. So those were this was the Level Up, or is the Level Up campaign. And during one of the webcasts regarding the Level Up campaign, I thought, well, in DFIR, it's quite hard to come up with good labs. And for me, good labs, good demo environments are very essential when it comes to excelling in cybersecurity, right? So at the moment out there are tons of cool tools, right? And there are usually also some sort of labs or exercises that help you to understand a certain concept or a certain tool. So having said that, probably many of you can think of tons of different memory forensic tutorials where you get a ready-made memory image and, well, for example, you figure out what the malware is, you get out some files that were dropped, and all that kind of stuff, malware configuration. But all of those things are just like the little jigs in a big puzzle, right? And it's very rare to find a lab that puts all that together like in a real case. And so for us, it might be quite tough to prepare in the DFIR field. So let's look at some other things that make up the status quo. So we do have those labs. And in my experience, so I used to work in my history before InfoGuard. I used to work for Mandiant. And back then, I was doing both incident response and red teaming. And my feeling always was that there are better and more pen testing labs than DFIR labs. And I think I know what the reason for that is. Penetration testing labs do have some features that are very hard to replicate at DFIR field, and I'll get to that in a moment. And what a problem, there's a problem that we are facing when we try to assess new employees, new candidates, or employees who probably want to go through the ranks and want to be promoted and all that stuff, because you can only put them on real-world cases. That probably works for internal promotion, but obviously I can't put a candidate on a real case. That wouldn't work that way. So we are in real need for good labs here that replicate the kind of situation that an incident responder might be faced with in an everyday situation. Okay, so that is where we are coming from, and the whole idea behind that was that in the end, maybe what we can do on our own, the community can do. And in that regard, I coined that LevelUpLabs Twitter hashtag to connect people who want to build labs together. Because there's one thing when it comes to a DFIR lab. On one hand, you need the network that you defend and that you investigate. On the other hand, you do need the attacker infrastructure. And if you want it to look real, both sides need to have at least some features that replicate what real attackers do and what real organizations look like. That's very important, and that's also something that makes the SANS labs. I can only talk about the class I'm teaching in the 4548 class, very unique, because they are, well, they are very well planned, they are very well executed, and that's really not easy to do. But I guess we can do a bit better than the average when we combine our forces here. But first of all, let's look why it's so difficult to set up DFIR labs. So first of all, a DFIR lab strongly depends on user activity to look real. Now let's compare that to a penetration testing lab. In the penetration testing lab, there might be some situations where you do depend on user interaction. One of the examples that I could think of is when you want to replicate what happens after a phishing email. So someone needs to click on that email, on the payload or whatever, to get that whole lab started. And I've seen labs out there in the wild who just automatically do some kind of stuff. Some others would be CRSF labs, where you want a higher privileged user to open a certain manipulated web page, and that leads to, well, whatever the attacker wants to accomplish, like adding a privileged user or something, or uploading something. Those labs that require user interaction and penetration testing as well. But for us in incident response, the user interaction is what makes a lab real, right? So it's very fundamental to these labs, because otherwise, and I've seen many of these labs when it comes to proving a certain point, testing a certain tool, where the image, when we're talking about like a hard drive image, for example, where the image was something like, okay, I install a new Windows copy. After I install that Windows copy, I do whatever evil stuff I want to do, execute the malware, do some other stuff in there, and then you shut down or freeze the machine, you get the image, and that's your lab. So that's not really difficult, and it does not feel real, right? Because in a nutshell, what you can say at that point is everything that does not relate to the Windows installation is essentially malicious, because there was nothing else going on there. So for us to make labs really challenging and good, we need to have user interaction. And I'm not only talking about legitimate user activity in a way that users work there, but also all that stupid stuff that people in organizations do, like downloading software they shouldn't download and run that, and all these kind of things, visiting websites they should not be visiting. You should have that as well, right? Because when you are faced with a real situation, you do not only have the attacker, you also have employees who have a very creative way of using our company machine. You might have even multiple attacker groups in there, and that adds a lot of difficulties to the investigation. Okay, so another point here in DFIR is it's costly. And the reason for that is I need to replicate a substantial portion of an organization's network to really do incident response. Again, I can easily test certain kind of investigation investigative features. So I can put like plug X Sogo malware on my machine and look at the artifact it creates. But what I want to see in a worthy lab in DFIR is something where you see not just the initial breach, you also see some lateral movement, you see someone collecting data out of the network, exfiltrating that data, and then probably leaving back a slow beaconing backdoor or something. And obviously that requires, well, quite some setup on the fake organization side there. And there is even another downside to it. For penetration testing labs, I've created these as well, right? The upside was you can just switch it off, right? When you don't use it, you switch it off, and it will not change a thing. For the DFIR labs, you can't just switch them off, because as soon as you interfere with in a way that you do something that's not happening on a real network, you will leave traces, and that might have impact on the investigation, on the demo investigation that you're doing. And keeping stuff online, because you would either do it on site, so it would consume space on your virtualization infrastructure, or you do it in one of the clouds, which is the way that I'm choosing, well, most of the times at least. And you have to keep that running for quite some time. And then it gets a little bit expensive, especially if you do not have a good business case on how to make money out of it. But to be honest, if you have a good lab to test whoever you want to employ, usually it's money spent well. Because, I mean, especially if you get someone from a headhunter, you don't only pay that person a lot of money, you pay the headhunter a lot of money. So you better be sure that you hired the right person. And for that, there's nothing better than real-looking labs that you could have here. Okay. Then the next complication here is you never know if you get what you're aiming for. And what I'm referring here is if you create a lab like that, right? You first set up the fake organization and all that. You set up the attacker infrastructure, but obviously you have some kind of a storybook on how this fake attack is going to happen, right? So what you do, when you set up that storybook, you obviously want to leave some traces, right? Not too many, but also not too few traces in a network. And the question is how good you can control if you're leaving certain traces. A good example for that would be volume shadow copies, right? So if you want to leverage, I mean, from the forensic side, if you want whoever to help the person who is doing forensics in a way that you might delete traces, but you want to make sure that these traces can be recovered from a volume shadow copy, you have two options. So either you try to figure out when the next volume shadow copy is going to be created, or you instantiate an event that creates a volume shadow copy. The option number 2 is not a good one, because that will leave traces of you initiating that volume shadow copy. So that leaves you with trace number 1, but that's a variable you don't fully control, right? Because even if you enter a command to check when the volume shadow copies happened last time, to sort of figure out when the next time is going to happen, even that little query might show up every now and then in some of the forensic traces. So it's the hardest part of setting up forensic labs is really not leaving any traces of the setup of the lab. So that's really very, very complicated. The next thing is, if you want to create an attack in that network, you need to really know how attackers behave, and not just from the forensic side, but also from the penetration tester side. And you really need to be good at it, because I've seen so many penetration testers who would not really get into many organizations if the organizations wouldn't be so lenient when it comes to security, right? Because they are so loud, if I can use that term for it, when they go into the network. And that's definitely not something I want to have in a lab environment. So probably I do not want to replicate, and I can't replicate the best kind of APT attack. But on the other hand, I do not want to have a script kiddie within that network, because that's definitely too loud. And the downside of that is that the training effect is probably not as high as if you have like a medium grade attacker here. And the hardest part is it's hard to reset. And that's especially hard if you pick one kind of a lab. Because when it comes to the types of labs, you do have two different options. Option number one is lab where you say, okay, I set that up, that organization, I keep it running for half a year. I basically replicate user behavior and all that during that period in time. And then I switch it off, take all the evidence that I have, or you leave it on and take all the evidence you get, and then you switch it off. And your lab is basically a collection of evidence, right? And whenever whoever runs that lab asks you for some input, you say, okay, if you would be like collecting the image of that machine, okay, this is the image of that machine. Here you have that, and you can work on it. So that's one kind of a lab. The other kind of lab would be something where you keep the lab running, and you even replicate the acquisition of the evidence. But that's, to be honest, really tough, because that means you need to keep the user simulation running. And I'll get to that. I did not find any tool that's usable in these kind of labs to replicate user behavior other than having humans do it. That's very unfortunate, and that's another reason why most people go for the like half-year recording kind of thing, where they have the network running for some time and then they execute stuff. And the problem is everything that you do wrong at that point will show up in the evidence, right? So there is no such thing like correcting later. If you, the only thing that you could do is to get rid of these traces is basically most of the times that you only change things in timelines, for example. But in the actual evidence files, it's really difficult. Even if you, for example, open up like an NTFS volume and you start deleting evidence that you left while you were running the lab, even that will show up if whoever is investigating that image later gets the full image and not just the timeline. So in other terms, never interfere with your demo network in any way that would not happen in the company network, right? So that gives you some leeway, but not very much, to be honest. And that's also what makes those labs very hard to build and especially hard to maintain. Okay, so how do you build that? And when I set up the talk, I actually had various options on how to do that. So number one would be very high level, then I would be done in like 10 minutes, including the introduction, and it would sound like something, well, if you want to build like a good lab, then look at, well, a medium-sized company and replicate the major infrastructure they have, then look at a few papers that describe how different attacker groups work and replicate that behavior. In a nutshell, that's what it is, right? That would be the short version. I'm now doing the medium version because the detailed version would obviously be too long, where I go into the different images and so on. And I actually started to do some sort of recordings on YouTube on how to set that up, and I have some lined up now. The problem is now that I'm open sourcing the Aurora incident response tool, that took so much of my free time that I couldn't post them yet, but I will continue doing that and showing you how to build up a, well, frankly, very small lab, but it's building a lab on a budget, essentially. And that will be a more detailed version of what I'm telling you now. So at the moment, in this part, it's more about which steps should you be doing and what kind of things do you need to do in these steps. Okay, so first of all, what are the steps? Obviously, planning. I would do that, otherwise it gets more expensive, and there's nothing worse than when you run the lab for 6 months, and after 6 months you realize that the data is worthless because you forgot about something. Okay, and then you create that environment, or environments if you want, attacker environment, victim environment, then you extract the evidence and you check the evidence for desired results. Okay, and I'm getting to desired results in a moment. Essentially, it means, is there anything in there that I wanted to the student to find, right? Is it really there, what I foresaw when I did the attack to be there? So otherwise, I can't just like throw that at someone and expect them to find anything if I did not check if it's even possible, and especially if it's possible in a certain amount of time that is given to the person. Okay, so let's go to planning real quick. What steps should you be doing? First of all, I would never run a lab when it's like those full simulation labs without a good background story, right? So most of the times, if you see an attack, the attacker wants something. If it's not a script kiddie who just like wants to get into the organization and look around a bit, there is some reason why these attackers are on that network. And for that reason, it makes sense to come up with a background story, right? So what is the organization doing that you're building? So what is the reason for them to exist? What kind of value do they have information-wise, and so on? So that's for the victim side. For the attacker side, what I usually try to do is I try to align it to real threat profile. So I want to replicate, for example, APT29 or something, I don't know. And there are many threat profiles out there, and the attackers are actually helping us today because there are so many attack groups out there who use Cobalt Strike to, well, do pretty much anything in the network. And Cobalt Strike is not exactly expensive, but Meterpreter will leave very similar traces, and that's free. So you could go for that, or you could go for a Cobalt Strike license if you're doing it bigger. Then it looks real. It looks quite real because we see so many PowerShell Cobalt Strike implants now. Well, so everyone and their brothers using that now. Okay, then when you set up that virtual organization, then I think it's clear that not all assets can be real. That would probably be too much, right, and too expensive. So one of your cost-saving questions is, what assets need to be real and which can be simulated or emulated, right? and that's very important there to figure that out pretty early on. So obviously, I will need a domain controller and a couple of machines, but maybe I can simulate some services, right? Especially, what I always do is when I plan something like that, I create like hackable assets and non-hackable assets. Does not mean they are really not hackable, but we did not plan to attack them, right? And all hackable assets obviously need to be real, because otherwise we wouldn't get the correct evidence out of them. Then we need to design the fake corporate network based on that data. We need a storyline of the attack. So when do we do what? And I would suggest to do that based on kill chain, right? So really go through that through the different stages of the kill chain and decide how to tackle the different phases of your attack. Because again, most of the attacks will match to the phases here pretty well. Okay. Then we need to review the assets again. So that's a point that I added lately to like my list on how I'm doing these labs, because you know, I'm a little bit chaotic from time to time, and for that reason, once the storyline is done, I oftentimes get carried away with the storyline, and at some point, maybe the assets, I mean, the distribution of assets between real assets and simulated assets do not really match after my storyline is finished. So I do a review again and check if what I set up in the storyline of the attack really works. And what you also need to try to do is you need to try to foresee what kind of evidence whoever is then investigating that breach will want from you. Because the problem is, if they want, like, for example, an image from a machine that's not really there, and it's just broadcasting stuff to the network with a simulator, then you can't give that evidence out because there is no such evidence. In that case, what I usually do is I just make up stories why they can't get that in time. Like, okay, you know, that machine is not offline, that's somewhere in the middle of Morocco, and you know, it's due to Corona, we can't fly it out right now. and there is no stable internet line to get that image or whatever over the network. So you just don't get it. Something like that. Then we need to plan the attacker infrastructure according to the storyline. And when we planned everything, we can come up with a price tag, at least an estimation for the price tag. And that does not include at that point the human actors that well, replicate the employees' work within the network. I'll get to that at a later point. So that's just for setting up and maintaining that fake infrastructure here. And you would be surprised how expensive that can get. Okay, now let's get to the setup. Well, obviously, set up all VMs and networks needed, and I'm gonna try a little demo here. Let's see if that works out. Usually it does not work when you do that live, but let's see. And set up all functions like you would in a real network. But you do have to be careful with everything that faces the internet, because as soon as you have any kind of attack surface on the internet, real attackers will pick up on it real quick. So our RDP honeypots, when we set that up, it takes like a minute or maybe two before the first one tries to get in. So just be conscious of that situation, and maybe try to separate the network on a firewall that's not visible to whoever investigates that, and open that only for your attacker connections, for example, right? If you need any outbound facing attack surface. Okay, then set up the attacker infrastructure. I usually do that way around because both takes time, and the longer your virtual machines, your virtual organizations machines run, the more real they will look, right? So it's really sometimes a matter of days that might make a difference, right? Just if you have like an update, a major update or something coming in, it will change a lot of things on the file system, for example. So that's what I'm saying here. Okay, then piling up data. Okay, and that's the tough part here. And that's also something that I've been looking into a lot. And I know that the authors of the 508 class, namely also especially Rob Lee, Chet, and so on, they were definitely looking into how to simulate user behavior. And there are some tools out there that can sort of play a user's role to a certain extent. The big problem with these is they are usually made for load tests and stuff. And that means they come with an agent, and you install an agent into the system on which you want to replicate the user behavior. And you can't do that in a DFIR lab, right? Because you will spot that immediately, that there is an agent running, and many of the processes were started by that agent. So that's only good for load tests, okay? And for that reason, I did not find any good solution. So if anyone has a good idea where you really have some sort of an agent, or some piece of software that really uses like VNC, the VMware VNC or something, to move the mouse and click on stuff and all that, then I'm totally happy to hear about it, right? But so far, I did not find a good solution for that, because that's the only way to really replicate a user in a forensic sense, so that the image looks real. Okay, then in addition to that, I would not just do legitimate stuff like chatting, sending emails, and so on, but also try to install some commodity malware. You know, someone was downloading some super cool freeware or cracked software like people do, and well, install that. Why not? And if you're really setting that up nicely, you might also want to come up with virtual characters in that network, right? That are sort of assigned to the different systems. And you can also set up real persona, like those people having social media accounts, even private email addresses where you might find data in password leaks eventually, all that kind of stuff, right? Just to make it look real. I mean, there are many attacks now where outbound or DMC Citrix servers or terminal servers have been breached if they did not have multi-factor authentication. So the first thing that we usually check, even before we get anything out of that network, is if for the user that the attacker used, there is a password leak somewhere, because maybe it's just password reuse or something. So you could even try to replicate that to make it look real. So you see, it's not exactly easy to set up something like that. And the last part, if we're talking about the labs that are switched off, is collecting evidence. If you keep the lab running, well, you can add the acquisition part to the training, like I said, but then you have to keep simulating users in the network, because otherwise, I said you can't switch it off, right? Because if you then switch it on again, you're gonna have like a blank spot for a couple of weeks or however long you switched it off, and you don't want to have that, because that's something that good investigators will spot right away. If you don't want to keep it running, make sure you get all data that might be useful to train the people, right? Like memory, like images, and so on. But also maybe acquisitions with the EDR solution you use in reality, right? That whoever you're testing with that lab can say, okay, if that was a real breach, I would now enter XYZ into my EDR, and then I would get data. And in that case, you should be able to provide that exact data that that person would get at that point in time. That might be difficult depending on the solution that you have, but it might be possible, especially if you install it in the first place. Again, be aware that everything you do from a forensic perspective might leave traces, right? So if you're checking anything while you are running that lab, these checks are something that might show up in the investigation in the end. So that's the very tough part here. Yeah. Let's just summarize the shortcomings before we go into a little lab here. Again, user behavior is really hard to simulate without an agent. There is some PowerShell kind of user behavior simulation. I forgot the name. But again, I cannot just run random PowerShell that then invokes like mail sending and internet browsing. That's something that an investigator would find out pretty quickly. Okay, so it takes time there, and it's like a black box. It's like Schrodinger's box here, right? Because you run the lab and you never know if it turns out the way you want it to turn out. So you only get that information in the end when you look at the evidence. And the other downside is when you're looking at the machine resources, you can always tell that this is a lab. Otherwise, the machines would need to be so beefy. I mean, if you're simulating a net or a like smaller company with like 1,000, or that would be a lot, right, for a lab. Let's say with 1,000 hosts, and you have an Exchange server that you simulate. Obviously, if there were really 1,000 users, that Exchange server would be quite beefy, and you would have a cluster and all that. And I'm pretty sure you wouldn't want to allocate these resources for a lab. It just gets too expensive. And one other downside in modern networks is we're only talking about IT right now and not OT, operational technology, SCADA, and so on. But we do have some solutions for that as well. So let's look at that, some little helpers that we have here. Let's get rid of that. I want to show you two different things, just like just to get you sort of started. And I know that might be small on your screen. Let me see. I try to make that a bit bigger. Give me a second, please. Well, it's not really bigger, just the window is bigger. So one tool that I really love to use, oh no, it worked, that I really love to use is called Imunes. And that's a tool, I think, that has been started in 2004 by the University of Zagreb. And it's basically a network simulator, but it gets a little bit further than that. I think there are some networking, simulators out there that do something like that. You even see the logos here, in that case, a router, switch, sorry. But this one is also focused on endpoints. And if you install it in Linux, you can not only set up the network components, you can also set up hosts, like you can see here, right? And the hosts are sort of powerful here, because what they do, in effect, is they are Docker containers. And that gives you the ability to not only simulate bigger networks than you have, but it does not only simulate the network, but also hosts. So this is like a very early stage. I can't show you the final one for something that for a lab that I was setting up. And this is the network setup. So we have like 3 different network providers here with their core switches and all that. And that's sort of my simulated internet. So it's not very long routes, to be honest, but well, you do get some hops. It doesn't matter really. And you do have different zones. So that's the God zone where the management systems are for the internet, like core DNS servers and so on. I do have one PC here that's attached to a provider called SoupNet. Obviously, there would be some corporate networks here as well. But for the ease of use, I got out of that. And they are all interconnected, right? I just put them into different tabs. And when I start that whole thing up, it will launch some Docker containers. Let's do that real quick. Not sure if I, okay. Just takes a moment. And the good thing about that is if you want to come up with some kind of like off-the-shelf infrastructure, like wikis or like some grouper solutions and so on, there are Docker containers ready-made for that. And I can just prepare them and call whatever Docker image I want. I think I can show you that real quick. I have a lag here because I think I did not assign too much memory to that machine, and Docker needs that. No, I only got the interface in that case. I need to switch it off, but I can show you later. Well, I can show you here. So you can select images and you can tell it what to run. So I can tell it what Docker image to host and all that. But I'm not going too deep. What I want to show you is I have 2 hosts. First of all, this one has the IP address. So where is my magnification? Let me see. So I can read it. So this is the IP address 31.3.40.10. And in another provider, in another network, I think it's in this one, we do have another PC with a different IP address. I don't care about that. And you can just go to a shell within that Docker container pretty easily. So let's see if the network works. 31.3. 32.10. No, sorry. That's this net. This one, 340.10. This is the one. And you can really ping that machine. It's probably too small for you to see right away, but it's working. Okay, so well, that's easy, right? I mean, you could also like run commands like curl if you have a network, a web server on the other side and all that. So I can show you the real stuff here that I set up because it's confidential. But there's really cool stuff going on that you can do with that. And you can even put in breakouts, right? So to real, or in that case, I mean, that's a VM, right? So every like physical interface as seen from that VM, from within the VM is actually a virtual interface, right? And I can add many virtual interfaces to one VM. And that means within a virtualized environment, I can set up a few of these machines running Imunes. And these machines can then simulate parts of different organizations. So now if you need the real machines in here, you can just hook them up to these networks pretty easily using vSwitches and all that stuff. Okay. So this is the setup, and I'll get back to the lab in a second because I have a little combination here. Second thing is how to simulate some easy kind of OT. And the easiest way to do that really is, I prepared something here for you. Let me just try to get that. Oops. Oh, let me see if I can make that a bit larger of you. How does that work here? Well, it doesn't matter. I can also use, I thought it would work with the plus, but it doesn't. Okay, sorry. I'll just use the magnification for that. When it's about simulating OT, the easiest way to do it, obviously, is a protocol that's well known and also implemented in some open source solutions. I picked for that example Modbus here. and that thing is simulating a small PLC for a centrifuge. There was an incident that was going for that, and I initially set that kind of thing up because we had two master students, and I wanted them to create some sort of machine learning baselining tool that could baseline what was going on in that case, for example, a centrifuge. They also did it on a traffic light, and I wanted them to detect the behavior on the actual protocol that Stuxnet created, right? I mean, not the exact one, but something like that, you know, spinning up and down the centrifuges and all that kind of things. And for that, you can simulate that pretty easy. So you can see it's not a lot of code, really. It's almost no code, really. So you can simulate that like this. And if you want to go for something that, for example, has been attacked by the Iranians frequently, there is one thing that is called TLS 350. Let me see if I can get a picture of that device. So this is the device. Okay, so it's a tank gauge for petrol stations usually, and they come with a TCP/IP interface, and they are very frequently bound right to the internet. You find tons of these. They're running on port 10,001. To be honest, when you go to Shodan, we can do that real quick. When you go to Shodan, many of the things that you will find there, sorry for my voice, I'm almost sick now. Many of the devices that you will find here are simulated devices, but not all of those. So when you go for 10,001, I already have filters set, but we don't need that to get the full numbers. Let's see, it's very slow today. Then you get something like this, right? So like 225,000 of these things. Again, many of these might be simulated, but not all of them. So they actually look real. And you can also try to replicate the behavior of that one, because there are documentations on the internet on what kind of commands they accept and all that kind of stuff. Okay, so now let's put that stuff together. So I can show you that real quick. This would be like the boilerplate code. Well, that starts basically the behavior of that. I do have a full implementation that I can share, but this is the small one that only implements one function. But obviously, you could implement the other function that this device has as well. And to do that, let's combine all that. Let's say this server is in reality an ICS device. I think you could even use a better icon because it's open source. You could bring that in. And what I can do is I can start a second shell. So let's just sort it out. So this shell on the left-hand side, this is my client somewhere on the internet, and this is my TLS 350 somewhere on the internet. And for that, I installed Python into that Docker container, and I think under opt I do have this simulator, and I just keep that running here, right? And you can do that on start. I just chose not to do that, but you could put in that this runs automatically at start. Okay, and now, as you can see, I just tried to enlarge that. So this is running now here. Okay, and on the other side, I just entered a command first. So I need to go to that IP address again, 31 with telnet. That's the protocol it accepts, 10. So this is it, and on port 10,001, that's the default port. So like this here, and then I just run that, and it's, oops, that's 10 too much. Yeah. So now I got it correctly, and you see that we have the inbound connection here. And one of the commands, and this is the one that Shodan uses, is the one to get like the summary, and that would be the command i20-100. When I run that, I get pretty much the same output that Shodan has, right? And this way you can set up this fake infrastructure pretty easily. But that makes those labs a little bit more interesting. I mean, probably not a tank gauge, but that was just a very visual example. I can also make that a bit bigger. Oops, that was wrong. So this is the output that you get. So pretty much the same thing. And yeah, so you can combine those things. And I could also have a breakout to a separate Windows machine, for example, or a set of separate Windows machines. So this combines really well with other virtualized infrastructure. And it comes with the upside of Docker containers and the nice ability to set up the graphics. And that's one of the parts when I needed to set up like a fake small internet that I struggled the most to find something where I can really design some sort of a small network in different layers and run that when on a mouse click. So this is that kind of thing. So I got quite a few questions, so let's get through it. So Gary says, if you need a program that moves the mouse around and clicks in Windows 10, there's Move Mouse, which is free from the Windows App Store. Again, then you would see the mousemover.exe, and the only thing is it keeps the machine from going to sleep. By the way, in pretty much every compromise assessment that we do, we find those software mouse jigglers because people install that to keep the machine from locking up. The problem is I don't need only the mouse moving, I need the mouse moving in a useful way. And that means like opening up a browser window, going into the window, finding the search box, putting a search term in there, clicking on search, then the different searches it does and the website it visits need to add up, right, to a story on how the user would do it. So that's something that's really more than just moving the mouse. Okay, another question, what software did you use and was it free? Could you probably clarify for what? So this software is free, and that's called Imunes. And I can show you the URL, I hope at least. So it's imunes.net. There you can download it. There's one thing that you need to note. The original version used to be only running on FreeBSD using the internal virtualization of FreeBSD. And when they switched it over to Linux, they started to use Docker. And for our use, Docker is more powerful. If you only want to simulate the network side to understand certain routing protocols and all that, that's what they do with it, then maybe the FreeBSD version is better because the overhead is not so high. So you're not interested in the endpoints, but rather in the network. Okay. Okay, if Docker container and you put a VM in the lab, how do you protect the base host? Well, I don't, because I run the attack, so I know what I do when I attack, and I'm not gonna attack the base host, the hypervisor. I'm not gonna do that. But in reality, if you expose it to the internet, that's a very realistic threat. That's true. And correct, the good investigator could detect Docker is running. Yeah, but the investigator does not get this machine here. This machine is just for hooking up all the rest. So the other machines will be running in VMware, which is also something that a good investigator, and probably if the VMware tools are installed, even a bad investigator would pretty soon realize. So that's true, but this is an image the investigator will never get, because that's just for hooking up things. So actually, that would not even be part of the networks that are controlled by the organizations that you investigate. So that's more like I'm setting that up for a different project that I don't want to talk about too much. But in this lab, there will not be one organization. There will be many organizations in that lab that are hooked up to each other in some way, as well as like home internet connections and so on. But that's a very different story here. Okay, I cannot see the commands at all. I can actually put them in here, but all I did was I pinged the other machine, and the other command was just connecting with telnet on port 10,000. I don't put the ping command in here, but the telnet command was, I just put in some IP because I don't remember the other one. So this is what I did for the connection. I put it in the chat. You should have it on the right-hand side of the window, right at the bottom of your GoToWebinar control panel. And once I was connected to the tank gauge, I put in I2100, which is the command that gives me the status for that for the tank or tanks that are attached to it. So this is really all I did, no more than that. And it's really not much about the commands, to be honest. Okay, so let's summarize real quick. Setting up forensic labs is really difficult because it's the job for investigators to figure out how things happen. And obviously, everything you set up and you modify is something that the investigator will find usually. It's really tough not to leave any traces. I mean, even if you set that up anew and everything, you might have the original Windows installation names of the machines lying around and all that kind of thing, right? So you can't get rid of that. I mean, the names, the host names that they lose after you add them or you join them to the domain. But yeah, that's just what it is, right? It's totally difficult. All I can do is just tell you some things that you don't make the mistakes that I made in the past. And I think we're all learning. So my call to you here is, if you want to set a lab up and you're looking for lab buddies, then just use Twitter and LevelUpLabs hashtag, and you will find the right people to help you out. Especially also the connection between red teamers and DFIR personnel, because ideally, if you're only a DFIR person, you shouldn't do the attack alone, right? If you never did that before, because it's not going to look real. And for a penetration tester, it can be a good test bed to understand what kind of things investigators will see easy and which kind of things go undetected for a long amount of time. Okay, so that was pretty much it. If there are no more questions, thank you very much for having me. And maybe I'll see you once we got more on-site classes again. We're starting that up right now. Michael, do you want to add anything?
No, not from my end. Just a quick reminder that if you had any further questions that were not covered during the webcast, you can always submit those to q@sans.org. That's just the letter Q. So thanks again, Matthias, for the awesome presentation, which helps bring this content to the SANS community, to our audience. We greatly appreciate you listening in. For a schedule of all the other upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. And with that, I'd like to wish you, until next time, take care, and we hope to have you back again for the next SANS webcast.